So oxygen sensors, aside from fuel injectors, are some of the most overlooked components. Oxygen sensors are like batteries. They have a usable lifetime. And they will go bad and they will actually operate, they'll be slow. So one main way of checking oxygen sensors is to check their speed. They have a swing, and when the engine is rich, and these are earlier oxygen sensors, these are not wide bands, these are narrow band oxygen sensors. See, a narrow band is good for around 7 to 1 up to about 15 to 17 to 1. If you get a wide band, it'll cover down to 5 to 1 up to close to 18 to 1. And that is a fuel to air ratio. But let's stick with narrow band oxygen sensors. Oxygen sensors, when the engine is rich, the pattern is up high, the voltage, and then when it's lean, the pattern's down low. And it goes through this swing. Rich, lean, and because what's happening is when it sees the engine's lean, it pushes it to go rich, and then when it sees it's rich, it pushes it to go lean. It's this cycle that the engine goes through with the engine management system. Oxygen sensors do one thing, and it's funny when I'm in classes and I'm teaching a bunch of high-level techs, I say, what does an oxygen sensor do? And the techs like to go, well, it changes the fuel mixture in the engine, and it does this. And I say, no. You know what it does? Sure, all of that's correct. It does one thing. It senses oxygen in the exhaust. That's all it does. And you have to have a sample to compare what's normal. So everything is built on a scale. Everything that we do, everything computers do, needs a scale to show what's normal and what's not normal. So it knows what's normal by picking just oxygen out of the air, and it uses that as a sample, and it compares what's in the exhaust. And between those two, it can tell the computer whether the engine's running rich or lean. So when the engine's running lean, the voltage is way low, and it tells it needs to be richer, so it opens the gap on the injectors, the pulse width, and then it goes rich, and as soon as it sees that, it goes lean. The quicker it goes from rich to lean and lean to rich, which is really 1/100th of a millisecond is the most you want to see. The quicker it does that, the more control it has over the fuel mixture. Oxygen sensors have to heat up to a certain point. Once they get to operating range, they will work quicker. As they wear, they get slower. And what you want to do is you want to make sure that you replace your oxygen sensors, I'd say about every 50 to 60,000 miles. You can go a little further, but it's a good idea to replace them more often. And you may say, well, it seems to be running okay. I have no problems, or I don't have any check engine light warnings. But what you're going to do is you're going to get a better fuel mileage, you're going to get a better performance, and you're also not going to wash your cylinder walls down with too much fuel when your oxygen sensors are working properly. Of course, it's a holistic approach along with the fuel injectors also. So keep an eye on your oxygen sensors, make sure they're not getting too old. Your fuel injectors should be replaced or rebuilt every 40,000 miles. And then, of course, the tune-up. You know, back in the day, a tune-up on a Model T was to use a tuning fork and tune the ignition system. Well, we got away from that, and a tune-up meant spark plugs, fuel filter, oil filter, valve adjustment. And now with the modern cars, there's no valve adjustment, and there's really no fuel filter to replace. So all we can do is we can replace the air filter, replace the spark plugs, and go out and drive it really hard and blow all the carbon out. The only way it's going to work out well is when you have a really good fuel in the car. A top tier fuel like a 92 or 93 octane, 91 if you're less fortunate. So between those things, that's all we can do. Make sure you drive your Porsche hard and keep an eye on the age of the components.